In this video, we are going to discussing about tricks to find the number of lone pairs and bond pairs. So, with the help of some tricks, we can easily find out the bond pairs and lone pairs, right? So, first we are going to discuss about bond pairs, right? Bond pairs is simple. First, we have to calculate the number of surrounded atoms of central atom. That means, take for example, ammonium molecule, right? So here nitrogen is a central atom, right? So nitrogen is surrounded by how many hydrogen atoms? 4, right? So therefore number of bond pairs is equals to 4. Okay, now next comes to BF3. BF3 is a central atom, right? How many surrounded fluorine atoms? 3, right? Therefore number of bond pairs is equals to 3, right? So this is how we can find out the number of bond pairs, right? Next comes to number of lone pairs, right? So we have one formula to calculate the lone pairs, right? First one is we have to calculate the number of valency electrons of central atom minus n into valency of the surrounded atoms, right? Here n is equals to number of surrounded atoms, right? Take for example, here first we have to calculate the number of valence electrons central atom, right? Take for example, in this molecule nitrogen is a central atom, right? So first we have to calculate the number of valence electrons of central atom. So here the valence electrons of nitrogen is 5, right? So I will write my 5 again minus n means number of surrounded atoms. How many number of surrounded atoms we have? 4 hydrogen atoms into valency of the surrounded atoms, right? Here surrounded atom is hydrogen, right? So valency of hydrogen is 1, therefore I will write 1. Therefore 5 minus 4 is equals to 1. Therefore here, so NH4 plus have number of bond pairs is equals to 4, number of lone pairs is equals to 1, right? Similarly for BF3, lone pairs of electrons. For first we have to calculate the number of valence electrons of central atom, right? Central atom is boron, therefore valency electrons of boron is equals to 3. Again I will write minus as it is n means number of surrounded atoms. How many? 3 into valency of the surrounded atoms. Here fluorine is the surrounded atom, right? So valency of the fluorine is equals to 1, so I will write 1. Therefore here 3 minus 3 is equals to 0. So in BF3 molecules number of bond pairs are 3 and number of lone pairs is equals to 0, right? So we will go with some other examples. Here first we have to go with bond pairs, right? So central atom is surrounded by how many fluorine atoms? 2, therefore number of bond pairs is equals to 2, right? Similarly for lone pairs of electrons, first we have to consider valency of the central atom, right? So for xenon number of valency electrons is equals to 8, right? So I will write 8 minus n means number of surrounded atoms. How many? 2. 2 into valency of the surrounded atom. So fluorine valency is 1, therefore I will write 1. Therefore here 8 minus 2 is equals to 6, right? In HCF2 molecules number of bond pairs are 3, number of lone pairs are 6, right? Next one HCF6, right? So number of bond pairs is equals to how many? 6. Similarly for lone pairs we have to consider for valence electrons of xenon. How many? Valence electrons of xenon is equals to 8 minus number of surrounded atoms. N means number of surrounded atoms, right? How many? We have 6, therefore 6 into valency of the fluorine. How much? 1, therefore I will write 1. Therefore 8 minus 6 is equals to 2. Therefore in this molecules we have number of bond pairs is equals to 6, number of lone pairs is equals to 2. This is how we can find out the number of valence electron, number of bond pairs and number of lone pairs, right? 2, right? First we have to go with bond pairs, right? So bond pairs is equals to number of surrounded atoms of central atom, right? So we have oxygen in central atoms surrounded by how many hydrogens? 2 hydrogens, therefore bond pairs is equals to 2. Similarly for lone pairs, first we have to calculate the central metal atoms valence electrons, right? So oxygen is central atoms, therefore here valence electrons of oxygen is how much? 6, right? So I will write 6 minus number of surrounded atoms. How many? 2 into valency of surrounded atoms. So here hydrogen surrounded atom, valency of hydrogen is 1, therefore 6 minus 2 is equals to 4. Therefore here number of bond pairs is equals to 2, number of lone pairs is equals to 4. right? Similarly for PCl5, number of bond pairs is equals to how many? 5, right? Next, lone pairs is equals to valence of central atom. Here phosphorus is central atoms, right? So valency electrons of phosphorus is equals to 5, right? I will write 5 minus number of surrounding atoms, how many? 5. 5 into valency of surrounding atoms, that is chlorine. Valency of chlorine is equals to 1. I will write 1. Therefore here 5 minus 5 is equals to 0. So in this compound, bond pairs is equals to 5, lone pairs is equals to 0, right? Next one, XF6, right? Here bond pairs is equals to 6, then lone pairs is equals to valency of central atom. Here central atom is sulfur, therefore valence electrons of sulfur is equals to 6, right? Therefore 6 minus number of surrounded atoms, how many? 6. 6 into valence of fluorine is 1. I will write 1 is equal to 0. 6 minus 6 is equals to 0. So in this molecule, number of bond pairs is equals to 6, number of lone pairs is equals to 0. Similarly for XCO3, number of bond pairs is equals to how many? 3, right? For lone pairs, central atom is xenon, right? So valence electrons of xenon is equals to 8, right? So I will write 8 minus number of surrounding atoms is equals to 3 into valency of oxygen. Valency of oxygen is how much? 2, right? I will write 2. Therefore 8 minus 3 into 2 is 6. Therefore 8 minus 6 is equals to 2. So in this compound, number of bond pairs is equals to 3, number of lone pairs is equals to 2. Okay na? Next compound, NH3, right? So here I will go with bond pairs, right? Bond pairs is equals to number of surrounding atoms, how many? 3. Therefore number of bond pairs is equals to 3. Similarly for lone pairs, central atom valence electrons is equals to how many? For nitrogen atom, 5, right? I will write 5 minus surrounded atoms, how many? 3 into valency of other atoms, that is hydrogen, is equals to 1. Therefore 5 minus 3 is equals to 2. Therefore in this compound, number of bond pairs is equals to 3, number of lone pairs is equals to 2. Similarly for PO4 3 minus, right? I will take for example bond pairs. So same number of surrounded atoms, how many? 4. Therefore number of bond pairs is equals to 4. For lone pairs, first we have to go with number of valence electrons of central atom, that is phosphorus, how much? 5, right? I will write 5. Then so we have to look onto the charge of the compound, how many? Minus 3, right? So here minus 3 means we have to add the 3 electrons, right? Then minus number of surrounded atoms, how many? 4, right? 4 into valency of oxygen, how much? 2, that is 2. Therefore here 5 plus 3 is equals to 8. 8 minus 4 into 2 is 8. Therefore 8 minus 8 is equals to 0, right? This is how we can find out the number of bond pairs electrons and number of lone pairs electrons. Now there is a small correction in NH4 plus, right? Number of bond pairs are 4, that is surrounded atoms is equals to 4. When it comes to lone pairs, first we have to go with number of valence electrons of nitrogen, right? So number of valence electrons of nitrogen, how much? 5, right? So 5. Again we have one plus charge, we have to go with charges only, right? Plus means how many electrons? 1 electron, so I will minus 1 electron. Okay now, then number of surrounded atoms, how many? 4 into valence electrons, how much? Sorry, valency of hydrogen is 1. Therefore here 4 minus 4 is equals to 0. Therefore number of bond pairs in NH4 plus is 4 and number of lone pairs is 0. So this is how we can calculate the number of lone pairs and bond pairs of any molecules, right? So some other examples, find out the number of bond pairs and lone pairs and mention the answers in the comment section. Thank you.